Let's do another type of question. Okay. In this question, they are saying particle A starts at a specific point. Okay. So they are saying 2, 3, 4, and moves with a velocity vector of I plus 2j plus 3t. Okay. So for A, the motion of particle A, we can write the vector equation R is equals to 2, 3, 4 plus T into 1, 2, 3. And they are saying at the same moment, okay, so the particle, another particle, okay, particle B is starting its motion at the same time period. And that can be written as for B, R is equals to minus 4 minus 5 minus 6 plus T into 4, 5, 6. The first question is, do particles A and B ever meet each other? Okay, so if the particle A and B ever meet each other, when the time period, sorry, for example, let's say when T is equals to T naught, if they are meeting each other, their position vectors, okay, the particle A and particle B should have the same position vector. That's the idea. Okay. So whenever you're dealing with these types of questions, always first of all write down the parametric equation. So for A, the parametric equations are x is equals to 2 plus t, y is equals to 3 plus 2t, z is equals to 4 plus 3t. Similarly, for B, the parametric equations can be given as x is equals to minus 4 plus 4t, y is equals to minus 5 plus 5t, z is equals to minus 6 plus 6t. Okay, so the idea behind this is, okay, if the particles are meeting at a specific point of time, since they are starting at the same time, the motion has been started at the same time. Okay, so we have to be clear that for a specific time period, let's say when t is equals to me, for t is equals to t naught, okay, the x, y, z coordinates of A must be equal to the x, y, z coordinates of P, respectively. Okay, so let's say when t is equal to t naught, well, the coordinate of A will be, okay, the coordinate of A, the position vector of A can be given as 2 plus t naught, comma, 3 plus 2t naught, comma, 4 plus 3t naught. Similarly, for B can be given as minus 4 plus 4t naught, comma, minus 5 plus 5t naught, comma, minus 6 plus 6t naught. And these should actually obey. This is a system of equations for t naught. Okay, so if I equate this, okay, 2 plus t naught must be equals to minus 4 plus 4t naught, which means 3t naught is equals to 6, which means t naught is equals to 2. So if they are meeting, okay, if they are meeting each other, the time should be equals to 2. Okay, let's verify this. If all the t naughts reduce to the value 2, well, then they are meeting each other. We can confirm that. Okay, shall we check? So in this case, we have 3 plus 2 t naught is equals to minus 5 plus 5 t naught, which means 8 is equals to 3t naught, where t naught is equals to 8 over 3. So the values are differing. Okay, the values are differing for specific points. Okay, so we can confidently say the particles do not meet each other. The particles, the particles do not meet each other. Okay, because at t is equals to 2, okay, at time is equal to 2 seconds. Okay, let's say this is in ms minus 1, velocity is in ms minus 1, and the position is in meters, and the time is given in seconds. Okay, at time is equals to 2 seconds, okay, at time is equal to 2 seconds, the A and B are in I axis, they are in the same point. Okay, in I axis, they are in the same point, but their Y and Z axis are different. Okay, their y and z axis are z coordinates are different. Okay, when time is equals to 8 over 3, they are in the same y coordinate. Okay, They are in the same y coordinate, but the x and z coordinates are different, entirely different. Similarly, you can see for z also. Okay, let's substitute for z. So we have 4 plus 3t naught is equals to minus 6 plus 6t naught. So which means 3t naught is equals to 10, where t naught is equals to 10 over 3. Okay, so all three values are different. So we can confidently say they are not meeting each other. They are not meeting each other. Okay, what about the second question? Do the paths of particles A and B intersect? Good question. Okay, so they are not meeting each other, but their path may intersect. I mean, like if they have the intersecting paths at maybe at different points of time, they can pass this point. Yeah. Let's say this is the motion of A, and let's say this is the motion of B. Okay. Their paths may cross each other, but they don't have to meet each other. I mean, B can be here when A is here. Okay. And A can be here when B is here because it depends on the velocity. Okay. It depends on the velocity. So if they are crossing their paths, which means their paths are intersecting lines. Okay. And we know how to check for intersecting lines. In that case, if they are intersecting each other, we can verify that by giving them different times. Okay. Let's say they are passing through if they are intersecting each other, they should have a common point. Okay. They should have a common point. So let's say A passes through the intersecting point. A passes, let's say this is Q. A passes Q at T is equals to T1, and B passes Q. Okay, B passes Q at T is equals to T2. Okay, so we will first of all check for X and Y and come up with the answers for T1 and T2. We will substitute that to Z to find whether it works. Okay, to find whether it works. So let's see. So we have X is equals to 2 plus T1, Y is equals to 3 plus 2T1, and Z is equals to 4 plus 3T1. And similarly for B, we have X is equals to minus 4 plus 4T1, and Y is equals to minus 5 plus 5T1, Z equals to minus 6 plus 6T1. That's it. Now we just have to go with the system of equation. Okay, so we just have to go with system of equation. Let's do that. So first of all, equating 2 plus t1 is equals to minus 4 plus 4t1. I can say t1 minus 4t1 is equals to minus 6. Similarly, 3 plus 2t1 is equals to minus 5 plus 5t1. So here I can say 2t1 minus 5t1 is equals to minus 8. Yeah. Yes. So here I can come with. So this is the first set of equation, and this is the second equation. And we also have third equation that we should verify. Okay, that we should verify. First of all, we'll come up with the values for T1 and T2. Oh, this is for T2. Sorry. These are T2. The T2, T2, and T2. Okay. So now, so T1 is equals to 4T2 minus 6. So I can replace this here. Okay. Sub T1 equals to 4T2 minus 6 in 2. So that will give me 2 into 4T2 minus 6 minus 5T2 equals to minus 8. So that is 8T2 minus 12 minus 5T2 equals to minus 8. So that will give me 3T2 equals to 4. So T2 is equals to 4 over 3. So T1 will be equals to 4 into 4 over 3 minus 6. Okay. And T1 will be 16 over 3 minus 6. Well, it won't work. However, why? T1 cannot be less than 0. It has to be greater than or equals to 0. Okay. So yeah, I mean, their paths cannot intersect. Their paths cannot intersect. That's it. If since this is not possible, okay, we can confidently say their paths do not intersect. We can say because no one can travel to minus 2 or 3 seconds. So we can definitely say their paths cannot intersect.
Thanks for watching the 21st video in our vector series. If you found this explanation of whether two particles meet or whether their paths intersect helpful, don't forget to like, share and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.